Hi, in this video we're looking at algebraic proof, and it forms part of the playlist by the same name. One of the difficulties with these sorts of questions is actually really just understanding the question before you set about looking at the proof. So it says, prove that the sum of the squares, of any two consecutive integers. So integers is just another maths word for whole numbers. So it's just a whole number, and they're saying that the square of any two consecutive whole numbers, so 3 and 4 or 8 and 9, is always an odd number. So let's prove that algebraically. So the first thing I'm going to say is, so the first whole number, the first integer that I'm going to use is going to be n. I'm just going to call it n, integer. I'm just going to call it n. Which means that the next second integer is going to be another number added to n, so it's going to be n plus 1. So the second integer is going to be n plus 1. So those are our two consecutive integers. The next thing is we've got to square each of these, and add them together. So the first thing is I'm going to square n, so I'm going to get n squared, and I'm going to add it to n plus 1, also squared. So let's have a look at how we expand that. Well, n squared is n squared, and then plus, and I've got n plus 1 multiplied by n plus 1. So that's going to give me n squared again, plus 2n plus 1. Now, I'm very aware that you might use partitioning, or you might use a different method of how to expand that. There is a playlist within the channel where you can look at expanding these double bracketed terms, so please do refer through to that playlist if you need to. So let's just tidy everything up. So I've got n squared plus n squared is going to give me 2n squared. I've got plus 2n and then plus 1. So prove that the sum of the squares of any of the two consecutive integers is always an odd number. So really what we've got to do is take this expression and just interpret it in the light of the question itself. Well, if we factorize the first two terms for 2, I'm going to get n squared plus n. So that bit of it is actually an even number, because anything that's multiplied by 2 is going to be an even number. It doesn't matter what number it is. If you multiply 13 by 2, you're going to get 26. Or if you multiply 6 by 2, you'll get 12. Or 8 by 2, you're going to get 16. Or 15 by 2, you're going to get 30. So this part of it demonstrates that as 2 is a factor of these two terms, then it must be an even number. But we've also got this plus 1 at the end, which basically will mean, because we're adding 1, it's going to be an odd number, and that would be sufficient to prove this particular case. So I hope that's been okay for you. Please do add a comment below if you're not sure about anything. I'll always come back to you. Have a look at the other videos within this particular playlist, and they'll give you a few more examples. I'll look forward to seeing you inside the next video.